NASA published almost nothing online before the year 2000, so a clip uploaded in 2015 is routinely discussing a result from 1976. If you sort this archive by its own metadata, you get the order things were posted, which is not the order anything happened. Everything you are about to see is real NASA footage. 87 clips, 4 hours pulled live from NASA's public image and video library. But an archive like this isn't really a video library, it's testimony. The real value is somebody on camera in 1965 saying what they thought Mars was, and being wrong, and somebody in 2015 saying what we know now. Titles and tags don't capture that. The truth is in the spoken words and in what was printed on the screen behind them. Today you can easily find a clip called Mars Report, but you cannot ask how understanding of water on Mars changed and get back the exact moments that answer it. And there is a trap here that took me most of the bill to solve. NASA published almost nothing online before the year 2000, so a clip uploaded in 2015 is routinely discussing a result from 1976. If you sort this archive by its own metadata, you get the order things were posted, which is not the order anything happened. My name is Rahul, and this is my submission to the VideoDB online hackathon. Ephemeris takes the question rather than the keyword. It gives you a cited answer, ordered by when the events actually occurred, and it auto-edits the evidence reel that proves it. Let me show you how it works. Let us see a pre-recorded query of how understanding of water on Mars changed.
Looking forward to paving the way for humans to go to Mars, because there's a lot we need to know about potential landing sites, where water is on Mars. We now know that there are areas of Mars that have huge subsurface glaciers with lots and lots of fresh water.
Before long, Spirit was covering up to 360 feet a day and shattering distance records along the way. The rover's initial work site was a rock dubbed Adirondack. Using its grinding tool, Spirit became the first robot ever to carve into Martian rock. From there, the rover ventured to other sites like Humphrey, Ebenezer, and into the Columbia Hills. It was in the Columbia Hills that Spirit finally hit the geological jackpot and found the mineral hematite. Hematite often forms in water that may have nurtured life on Mars.
The mission will allow scientists on Earth to study Martian terrain too dangerous to visit. It will also help determine which future landing sites might yield the most science. This information will become increasingly important in years to come as NASA plans missions to the Moon, Mars, and beyond as part of the vision for space exploration.
Beneath the thin atmosphere of Mars lies an...
As you can see, the focus of the camera in the space changes with what is mentioned in the video clip. Also, you can see a generated summary of the query here, which takes in mind all the clips we have uploaded to VideoDB. Also, this is the timeline generated. These are 8 dated points spanning from 1965 to 2024. This is ordered by when the events happened in reality, not when NASA uploaded the file. Also, you can notice the citation numbers here.
Beneath the thin atmosphere.
And as you can see, you can click these citation numbers here or the timestamps here or in the timeline to navigate to any part of the reel generated. Now let's try asking it something in real time. How is the sun studied by scientists and what have they found till now? As you can see, it is searching across all the indexed scenes from the database, and you can also see the live progress here. Like now it has decomposed it to 4 sub-questions, and it is also doing more processing here. And as you can see, it has generated the reel in only 98 seconds. Let's see what it has generated.
There are more comets observed, not because there are more in the solar system, but because we have better ways to see them. Spotting a sun grazer from the ground is difficult because of the blinding sunlight. Now, spacecraft designed to observe the sun make the job a lot easier. Since the joint ESA-NASA mission SOHO launched in 1995, it has shown us thousands more comets than any tool before. To date, it has found 2,387 comets. With SOHO, we can now see the smaller, fainter comets close to the sun, just long enough to add them to our list of sun grazers before they vaporize. The spacecraft's data is available online, so now anyone can discover a comet. Roughly.
This CME just started off here.
So as you can see, it generates video containing different clips from different timelines and arranges it in a chronological order, which makes it easier to study how things progressed in the real time. You can also revisit your already asked questions and timelines from the past. Let's see how things work in the backend. In the first build-time step, the first step is fetching the data from the NASA asset URLs. This is done using this method in ingest.py. Then in build.py, the project uses this command to feed the spoken words and OCR into structured VLM. Then 5 indexes are generated, and the scene semantic and scene facets are generated using the VLM artifact. So now it has a knowledge of all the uploaded clips and it can search using these indexes. Now the second part is the query time, where the user asks any query. So first it is decomposed into sub-questions and phrasings. Then there is some filtering applied in which it is checked whether the query can be answered with the data provided in the video clips or not. Then in the retrieval step, it searches the clips through semantic search and generates a list of possible candidates. Then it is passed through this pipeline. So what this pipeline does is it filters all those selected clips and it generates and it puts them into a chronological order. And also it keeps in mind of the diversification, like I have put a max limit of 3, which is the number of clips that can be from a particular video in the reel. So this helps. So this avoids the reel being only taken from 1 video or 2 videos. Then the synthesize step generates the cited answer. The compile reel step compiles the reels, and it also stores all this information in the form of a JSON. And in the front end, I use Next.js plus React Free Fiber to represent the 3D space that you just saw. And all this data is linked with the presets present at this path. So everything is synced in real time. Like all the clips from the timeline are mapped with the assets present here. So it simulates focus on the relevant object while playing a particular clip. And it also has a system store in which one active evidence index acts as the whole sync bus across these 4 unrelated components, which keeps all these things in sync. Thank you for reviewing my project.